Hello guys, welcome back. Today we are going to understand today Leetcode question. This is our daily Leetcode question series, right? So let's understand what the question is saying that. So the question we have given today is 623 add one row to the tray. Means we have given a binary tree and we have given two integers, the value and the depth. So what we have to do, we have to add one row, right, on the given depth, right? Note that the root node having the depth is 1. So this is the rule that it is saying that to follow, right? So go and read this, so it will be little easy for you. Let's suppose this is the first example we have given. So example 1 we have given that we have this is the root, right, and whole tree about like 4 to 6 3 1 5, right, we have given. Then we have given value and depth, right, two integers we have given. So what it is saying, at this is the level 1, right, depth is 1. So on depth 2 means at depth 2 d equal to 2, here we have to update the values, right? We have to insert the value, not update, and the rest of the value will come down. So you can say this is the new you can say values node came here, and the rest of data has gone down, right? We can say rest of the node is gone down as a children. So what you will observe that for example 2 also you can see we have to understand that the current depth is d equal to 1, means depth is 1. Next is depth 2, and similarly it go to depth 3, right? So as you can see here, right, we have given depth 3 means d3 here, right? So what we have to do here, we have to insert a new row and the rest of these nodes will become its children, right? As you can see here, it became a new node and its children goes down, right? So very simple example. If you observe that what you will do, let's suppose the first example, right? So here let's suppose in between, right, in between this and this, right, if we'll take a temp, right, temp, and then we will swap with this one and this one, right, then it will happen, right? So we can say current left of you can say current node is what, the root, right? So if we say root not null, if root doesn't have not null means 4 doesn't have null means it has children, right? As we can see we have 2, right? So what we will do, the temp dot left equal to root dot left we will do, and then we'll say root dot left equal to root dot left dot val equal to val, and then we'll say temp dot right equal to null, means you know the swapping, right, the swap concept. We will swapping like that, right? We will do that. So it's very easy for left node and right node also. Similarly what we will do, we will do if root dot right equal to null, right, and then what we will do, root dot right we can say, and then root dot right dot val equal to val we will do, right, and then temp2 dot left equal to null. So it will automatically it will swap, right, like that we will do. So what I'm trying to say here, give me 1 second, better I will clean and then I'll okay I'm saying, so we have this is the left, right, so it is not null, right? So if I will take a temp, right, and we'll say temp will come between here, right, between here. So temp dot left equal to what we will do, temp dot left equal to this root, right, is current is root node, right? So we'll say equal to root dot left, right, root dot left. So automatically it will come here now, right, as a new node. So its children root node children is now temp node, and temp node left is now this node, right? And like that we will move ahead, right? And for iterating depth, what we will do, we in the DFS will pass current depth is 1, right? So whatever we will pass, like root we will pass, and then we'll pass was we can say depth we have, right? So each time we will increase the depth, and this is your real depth and this is your depth, right, like that we will do. So once we will reach depth and real depth, right, it will match, then we will do this we will insert a temp and then we will swap the values, right? Similarly we will do for this one. I think you got it, right? So let's see, this is the program I have done, right? So let's wait, I have written on a single page. So you can see what we have done. First we have given root, right, then we have given val, and then depth we have given, right? So first of all, if we'll check if it is on the depth is equal to 1, right, is equal to 1 means if the depth is already 1, means we have to insert on the root node, right? So we can say this is our new root node, right? And we'll say val, right? And then we'll update new root dot left as a root, right? And we will return new root, right? Then we will move if that is not the case, right? That is not the case, means I'm trying to say we have something like this, right? Some this is your root node, right? And this is your left and this is your right. So I'm trying to say if this depth we have given as 1, because its depth is what, 1, right? So what we have to do, we have to insert a new root here, new root, right? Like this, and we will treat as a its children. So not here you can say, but you can say here we'll say new root, right? Like this, and its left children will become like this, right? So we have done like this, okay? And then we will create one you can say recursive function dfs, and we'll pass root, then we'll pass val, then we'll pass 1 as its value, right? And the depth, right? We will pass, and then this is your, we will return the root. How we will do that? So the dfs method we have created here internally, so it will iterate each time. How will it will iterate? So current root is your node, right? Let's suppose it's node, then we have depth value we have given, current depth is 1 and the target depth is this one, right? So we'll check if the current node is null, we will return there, we will not do anything. But if the current depth, the real depth and the target depth matches, right? So current depth equal to target depth minus 1, means we have reached there, right? So what we will do, we'll create one left, and we will create new you can say left node will create and right node will create, right? From the val, right? Means the node having 1 value, that you can say like this, and it's as a null, we can say it's having null children and null children, right? Like this we have 2 left and right node, right? Val is 1, right? So we have created. Now what we will do, from the left now we will update the value, right? This value will update. How we will update? The left node dot left means these children, right? Now it's a node dot left, whatever the parent we have, means this is your node, I'm saying this is your node, and this is your left, right? And this is your right, right? So let's suppose this is the original one, root 1, right? So what we will do, here we have to insert, right? Let's suppose here we have to insert, means this will between that we will come one more node, that is 1, right? So how we will swap that? So we'll say its node means node left node, right? This will become the node of 1, right? Node of 1, left node of left node right, right? That is the, here we have written left node dot left we will do, and then we'll update its value from where, this current node, what we have, node dot left will update. Similarly we'll do right node dot right, from this value, right? From this one we'll update one more here, and it will become the right node dot left is now the node left, right? The node dot left we have, that is right, that will come here, okay? Similarly we'll update its node, right? The node values will have, now it is not pointing to here, right? Currently it's pointing to here, okay? And it's also pointing to here, but we have to update this to this, right? Means node to 1, right? To do that, node dot left equal to left node, and node dot right equal to right node we will do, and then we will return. And finally what we will do, the dfs node dot left, then we will do val, right? And then each time we'll update current depth plus 1 and target, and similarly we'll do for the right current depth plus 1. Each time we will move, like first we'll go to this level, then we'll go to this level, similarly we'll go for this level, right? Like that we will move, right? Each time, okay? If we have children, it will move like this. To move like that, we have to iterate one by one. So dfs is iteration method, right? You will say depth first search, you can say is a it will go to each depth, right? And it's very good to go with the depth first search approach, and so this is how we have implemented it. So if you talk about the time complexity and the space complexity, it will come number of nodes, right, based on the number of. So we can say time complexity and space complexity is also O of you can say O of n, right, you can say O of n, right, like this will come, and a space will also come O of n, right. So it depends on in the best case the number of node we have. If it is on the root, so it will O of 1, right, and for the space also, so like space will remain same, but the time will become O of 1, right. So thank you guys, thank you for watching this video. If you like this video, please hit subscribe this channel, so you will get more videos like this. Please also suggest that you really like this video and you want a different topics that you want to cover on the DFS, on the data structure and algorithm, and let me know if any problem have in the Leetcode question. Thank you guys, thank you for watching this, and you are a expert Funda family. Thank you, bye.